Welcome students in Calculus 2. Our topic for today will be the power series. So what we have seen so far and we have studied it in much details are the series. And if you just recall what a series is, just a summation. You start from somewhere to the infinity and then you have a sequence, we call it AN. And what we used to do is we want to check whether this series converges to a number if we add all the elements, or it will be diverges, means the answer would be infinity minus infinity or does not exist. And that's simply, we have so many tests to do this. If you remember, we have the comparison test, we have the root test, ratio test, and so on. And by using one of those tests, we definitely can see whether this series converges or diverges. Now, what I will add as an extra here is the following. Again, I will have a series, okay? But now I will add to it something, for example, x to the n. And this is what we call it power series. Why we call it power series? Because first of all, we have power of x. We have x squared. If I expand this one, it will look like polynomial that we used to see, a1x, and then the power will get higher with the time. So it is similar to the polynomials that we always like, but this time it will go to infinity. It will never stop. And now the question is, can I say this is converges or diverges? Of course, the answer should depend on x. So for some x, this will be converges, and for some other x, maybe it is diverges. So again, converges and diverges, these are depends on the value of x. Okay. Now this is what we mean by power series, and this is our topic, is to find the value for x where the power series converges. Now, if we look at this one here, the general shape for the power series looks like this. This is the general shape. And this number, which is come behind x, sometimes we see it, sometimes we don't see it. We call it the center. In our previous example, I don't have anything behind x, so my center was 0. So just be careful. Sometimes there is x minus something to the power of n. And it's really important that you know what is the center, because everything will depend on the center. So it's crucial that we know the center. Here the center is 0, and here the center is c. Now, if we want to find where this power series will converge or diverge, we have a very nice theorem saying that this is the picture that we will have. The power series will always converge in what? In certain interval. It will not just be separated points. They will become like an interval. And this interval, the middle point is the center. So something like this picture. We have the center in the middle, and everything to the right converges. Those are the value for x. And this r, we call it the radius of convergence. Radius of convergence. And that's exactly what you need to find. You need to find r, so that you need to know how long your interval is. So finding r will tell me how long my convergence or interval of convergence is. Now this r can be as long as it could be. It can be even infinity, which means everything converges. And it can be as small as nothing, which is 0, so only converges here. So imagine this r can be finite, infinite, and can be 0. It can be anything. Your task is to find this r, the radius. and that's what we will do in the next couple of examples. So the picture that we will have is the following. Either R will be finite, so only small part will be converges left and right of the center. Maybe it will be infinite, so everything converges. Or it will be R equal to 0. So just let me write here down. This is R equal to 0, this is R equal to infinity, and here R is any finite number, 5, 7, 6, whatever. Okay. Now if R is 0, only this one converges. Just keep this in mind that we always will have a convergence at the center. That's for sure. Now, how do we find this R? How do we find the interval of convergence? That's what we would need to do next. So I will do one example. I'll explain everything, so please focus with me in this example as we go along. Now, first of all, I have a power series like this one. The first thing I do, usually, I find the center. And since there is no number behind the x, the center is 0. So I know that my interval will have the center as 0. Now, if we have something like this, we use either the root test or ratio test. Depends on you. Usually I will use the ratio test. Okay, just let me go ahead and use the ratio test. Now, do you remember the ratio test? You need to find the limit as n goes to infinity of two things, an plus 1 over an. And here, what is your an is everything including the x. So an is everything. This is an. So we go ahead and we write it. Now, what is an plus 1? Well, actually, it's the same, but you change every n to n plus 1. And now what you need to do is the following. Just you have stack out of 4. You just have to maybe play with it a little bit. First of all, I will write the x at the end. Now, -1 and -1, because of the absolute value, they will cancel out, but I will just keep them for now. N plus 1, 5n plus 1, and then in the yellow, I just write the rest. And now we do cancellation as necessary. -1 to the n, -1 to the n minus 1. We cancel, we have -1, but because we have absolute value, that will give me only plus. So we will end up with n over n plus 1, and here we'll have 5, because we cancel 5n with 5n, we get only 5. So this one with 5. xn with xn, so we have only one x, and don't forget it should be between absolute value. Now, of course, x and 5, they have nothing to do with n, so they can go outside the limits. And then we have just this easy peasy limit, which can be used by L'Hopital. How much is this limit by L'Hopital? Is equal to 1. So the only final answer is absolute value of x over 5. That is my limit using the ratio test. Now you have to tell me, if I use the ratio test, I'm looking for convergence. To look for convergence, using the ratio test. What should we do using the ratio test? So to look for convergence using the ratio test, the limit must be what? The final answer must be less than 1. So that's what I will do next. Next, I will take this limit, okay, which is x over 5, and I will write it as less than 1. Why I write it less than 1? Because this is where I will get convergence. Now this is a very simple inequality. Move the 5 to the other side. We get this one. Now how do we get rid of the absolute value if we have absolute value, if we have inequality? Now if you don't remember, let me just remind you. I will go here. X, or let's say y, or whatever my variable is, less than any number a. If you don't want to see the absolute value, you have to write minus a, you have to write a, and here you write whatever in the middle. And then you solve it. And that's exactly what I will do here with this one. It will become negative 5 and 5, less than, and x in the middle. And that's it. Here we find my interval. My interval is between minus 5 and 5. So you go ahead and draw your number line. Remember, the center should be in the middle, which is 0. Now, x between 5 and minus 5, so this is 5 and this is minus 5. And now, here we have convergence all the way. Okay. Here we have divergence. Here we have divergence. But there is only one thing that you need to keep reminding yourself, is you don't know what happened at exactly 5, and we don't know what happened at exactly minus 5. Why? Because at 5 and minus 5, the answer will be equal to 1. Now, if you remember in the ratio test, if we have the limit exactly 1, this means the test is inconclusive. You need to check it by another test. So this side is divergence, this side is divergence, but those are question mark. So how do we do them? We just check them separately. So next, check the endpoints separately. Now, what do I mean by check the endpoints separately? If x equal 5, what will be the series, the original one? We have to go back and see our series, and we substitute, instead of x, we substitute 5. So it will be negative 1 to the n minus 1 over n, 5n, 5n. Now 5n and 5n will get cancelled. So what we will get is negative 1 to the n minus 1 over n. Now this is a famous one. This is, we call it alternating harmonic series. And we know that the alternating harmonic series always converges. We know this. So what we get is the following. At exactly 5, the interval is closed here. Closed means 5 is included in the convergence. Now, I think if we can do negative 5, everything will be the same. over n. Now this one I can rewrite it as the following. Take the minus 1 here as common factor, so minus 1 n minus 1 minus 1 n 5n and 5n. There is cancellation, 5n and 5n. Now minus 1 to the n times minus 1 to the n, this will give me plus, so we'll have just a minus 1 in the top. So we get minus 1 to 2n minus 1 over n. Now minus 1 to square is 1, so this will give me only a minus 1 over n. And this is harmonic series. It's not alternating, it's always minus. And it's diverges. So it's diverges. And then we have to go back here, erase this one here, and just do like this. That's exactly what we have here. So we just need to summarize what we did. And what we did is the following. Interval of convergence. This is the final answer if you want to. As -5 open and 5 closed. The radius of convergence is, now we have to go back to our picture and see how long from here to here. I think it's easy, you can notice it very easy, it is only 5. So my radius of convergence is r equal to 5. And that's how we finish this example. The next example, we will do 2 more examples and see what's the interval of convergence and the radius of convergence. This topic is very important, so please go to the WebAssign, practice. As much you practice, as much you will get the idea and you will absorb it. Thank you for watching.